In Rhino, there are a number of different geometry types we can use to create 3D models. Rhino typically uses geometry types called NURBS geometry, which stands for Non-Uniform Rationalized B-Splines. NURBS geometries are built from mathematical equations that are typically defined by a series of control points. Let's take a look at a few of these geometry types. I'm going to come up to our perspective viewport and make it full screen. Let's take a look at the points geometry first. Points are typically used as guides for locating parts of other objects in space, and they don't really add much to your 3D model. I'm going to type in point into the command line, and Rhino's going to ask us to specify the location of a point object. I'm going to click arbitrarily in space, and you'll see we've created our first point, which appears as a white dot in space. We can create points in a number of different ways. If I type point again, I can specify a specific location, so 0, 0, 0 at our origin point, to create our next point. There's actually a shortcut to how we can create points at our origin, however. I'm just going to undo this point with the undo command, and I'm going to do a marquee selection and delete the other point over here in space, and then I'm going to type in point again. And this time, instead of typing 0, 0, 0, I'm just going to type 0 once and hit return, and you'll see our point appears at the origin point. Whenever we use a command in Rhino, we can actually hit the spacebar again to repeat the previous command. So let's hit the spacebar, and you'll see the point command hits again. So we can easily go and hit spacebar and click and create lots of points all at once. Another type of geometry you'll commonly use are curves. Curves can also be used for locating objects in space, but they're also useful for geometry creation as well as line drawings. There's a few types of different curves we could create. We could create a line by typing line into the command bar. And the line will ask us to specify the start of the line and the end of the line, which we can do by clicking. We can also create a polyline, which works by clicking once, and then you'll be specified to click again and continue until you hit return to complete your polyline. We can also create a control point NURBS curve by typing in the curve command. This will work similar to the polyline command, except it'll create a curve of best fit through some specified control points. You'll see how this curve doesn't actually flow through the direct points that we've created. Just hit return once you're done. If we wanted to create a curve that went directly through all these control points, we'd have to use a different command called interpolate curve. So let's type interp curve into the command bar. This time, when we click, you'll notice that the curve fits perfectly through the points that we're specifying in our screen. We can also easily create polygons. So let's type in polygon, and I'm just going to create the standard one that I've got here, which is a hexagon. I'm going to click once and specify the radius. But if you remember, I talked about how you always want to watch the command line, and we can actually affect the type of polygon we're created through this. So let's hit return, and we're going to now go up to the command line and change the number of sides to 5 to create a pentagon. So now I can click on screen, specify the radius, and I'll create a pentagon. So always watch that command line for options that you can change in your commands. Another really common geometry type in Rhino are surfaces. Surfaces are one of the main building blocks for geometries in Rhino. They're single skin geometries that can always be unrolled into a rectangular shape. Let's use the plane command to create our first surface. I'm going to specify the first corner of this plane, and then the other corner, and then we've created our first surface. We can also create surfaces within closed curves. I'm going to create a circle just below our plane, and then I'm going to select the circle, and I'm going to use a command called planar surface, and this will infill a surface inside that circle. Now remember, I mentioned before that these surfaces are actually underlying rectangles, so we could use a command to unmask what this surface actually is. That command is called untrim, so let's type untrim into the command line. It's going to ask me to select the edge of the surface to untrim, so I'm going to select the edge of that circle, and you'll notice we now get this rectangular bounds of what the underlying surface is. We can go ahead and trim this geometry out by using the trim command. I'm going to select the curve as my cutting object, and then select the outside of the surface to trim back so we get that circle again. So just remember that any surface that you create in Rhino can actually be untrimmed back to a rectangle. It's just a mathematical equation that's set up that's the basis for all the geometry we're using. Polysurfaces are the other major geometry type we will use in Rhino. They're essentially a collection of surfaces joined together. For example, let's create another box, and this is an example of a polysurface. I'm going to type in box. Now this box is actually made up of 6 smaller subsurfaces, and we can show this by using a command called explode. So let's select it and type explode into the command bar. Now you'll see if I click off, I can select each of these surfaces one by one, so it's actually made up of smaller subsurfaces. I could then select all 6 of these subsurfaces and join them together, and you'll see in our Properties tab that we've created a closed poly surface. Now, a closed poly surface is basically telling us that the poly surface that we have has no holes in it, but it indicates the existence of something that's called an open poly surface. Let's use a command called delete faces to delete one of these faces of our poly surface. So I'm just going to go here and click on this front face, and I'm going to hit return. And now we've got an opening, and when we select this poly surface, you'll see in our properties, it's now an open poly surface. So this encapsulates most of the NURBS geometries we'll be using inside a Rhino, but there's also other geometry types we'll typically use in lots of our workflows. One of these geometry types are called meshes. So meshes are a collection of small triangular or square faces that attempt to approximate curved geometries. For example, let's create a sphere. I'm going to type mesh sphere into the command line, and it's going to ask me to specify a center point of the sphere and then create the radius of it. So you can see straight away that this sphere has all these kind of jagged edges. It's made up of a collection of smaller faces that are trying to approximate the curvature of the sphere. We can actually create a NURBS sphere inside of Rhino really easily as well. So let's type in the sphere command. This is actually a surface, so I'm going to model it with my other surfaces. The NURBS sphere is actually a mathematical equation. It doesn't really exist in real life. It doesn't have any faceted faces, unlike the mesh sphere. The mesh sphere serves as an approximation of what that sphere is. You can adjust some of the options in the command line when creating a mesh sphere to make that approximation a little bit less defined and increase the number of faces on that sphere. You can also create other geometry types with meshes, such as a box. So let's type in mesh box and create one of those as well. Specify the corners and the height. And there's a whole collection of other mesh geometry types that you can create inside of Rhino. Another newer geometry type inside of Rhino that was added in Rhino 7 is something called sub-D. Sub-D is a spline-based polygonal geometry type that allows for the creation of accurate, continuous geometries. It's a great tool for freeform modeling and sketching, and we've got an entire course on the different design available if you want to learn more. Let's create a sub-D box, so let's type in sub-D box to the command line, and it's going to be the same process to our other sub-D creations. But you'll notice when we created it, it looks quite blobby and strange. Sub-D geometries have 2 visibility settings. There's the smooth setting, and then there's the unsmooth setting. And you can actually toggle between these using the tab key. These forms exist to give you greater control over your sub-D modeling. Another geometry type inside of Rhino is the text type. We can go and add text into our 3D model. So let's go and create some text to label some of these categories we've created. I'm going to type text into the command line and hit return, and I'm going to type in points because I'm going to categorize my points, and then I'm going to make the height 0.5. And the command line is going to ask us to specify a location, so I'm just going to put this above my points. And so I'm going to skip ahead and let you go and add the rest of the labels to your scene as well. There are also many more geometry types like point clouds, dimensions, and text dots that are available in Rhino that can be helpful for a variety of different modeling tasks. So I encourage you to explore all of these as well.